And this is how multi-cluster management can look like in a GitOps-based platform. Hello. We are talking about the core of platform engineering, which is GitOps today. So first of all, let's start with a little introduction about what GitOps is. GitOps is a technology where we have a single source of truth for all of our infrastructure in a Git repository. This means all of our configurations and deployments are kept in one Git repository, or also multiple Git repositories, but in one place. And we have a single place where all of the truth is kept. So we can easily reconcile our existing infrastructure and all the bits and pieces around it from this repository with a GitOps tool. I will refer to this in this session today as a CD tool, and I will now show you how this works. So first of all, we will have some Git repository. I hope everybody is firm on what the Git repository is, in which we have some files. And the interesting thing is that we have all the features of Git, so we can use commits and pull requests and all the Git features to manage our infrastructure. We could also use branches and stuff like that to keep different versions. And then we have a tool, a CD tool. I will come into detail later what this is, which interacts with this Git repository in a read-only way to get the target state, the desired state, and then apply this to our Kubernetes cluster. So we will not interact directly with the Kubernetes cluster anymore. So our dev or our admin will not access the cluster directly to deploy stuff, but we will just interact with Git. This makes sure that we don't have any version draft, and we can always have the history in our Git repository. That's GitOps in short, and now I will explain why it's important to use GitOps for your platform. The nice thing is that we have a central space where we can have all the configurations, and it is easy to manage configurations for multiple clusters in this Git repository. So we could also have multiple clusters as targets to deploy to, and for the developer or end user it will still be the same interface through a Git repository. In the platform we could also have some kind of web interface, for example, as a self-service portal, which could then interact with the Git repository and put files there, for example, so our devs can leverage all the features without needing direct access to the clusters. The interesting thing with all this GitOps is that we can have defaults for all our clusters. For example, we maybe want to have an ingress controller on all of our Kubernetes clusters with the same configuration or a similar configuration, and this could also be easily done with the CD tool. So that's the basics, and now let's dive deeper into the multi-cluster management. So, multi-cluster management. What does this mean? For a platform, we for sure will have multiple clusters to run workloads. Either it can be different stages, different teams, or different projects. To visualize how these clusters can be managed together with a tool, with a CD tool, for example Argo CD, I will now show you the basics. So normally you would have some basic shared service cluster which runs our infrastructure components, for example Argo CD, that manages our fleet of workload clusters. This shared service cluster needs some infrastructure where it can deploy stuff. So, for example, a supervisor cluster, which is based on the cluster API. In this example, I'm talking about VKS, which would be the Kubernetes solution of Broadcom. This supervisor cluster, as already mentioned, implements the cluster API, which is the upstream standard for cluster management. We can then link our shared service cluster, or to be exact, the Argo CD instance in our shared service cluster, to the supervisor cluster, and then deploy the clusters, the workload cluster, via the supervisor cluster. So the shared service cluster runs an Argo CD instance, which sits, for example, here. And this Argo CD instance can access the supervisor cluster and deploy stuff over here. This supervisor cluster then creates the workload clusters, and Argo CD then can also access those workload clusters with a little bit of magic in generating some secrets and syncing them back to the shared service cluster. This is a nice way to have all our workload clusters managed from a Git repository, because as we already know, we can have some Git repository which our Argo CD is getting the state of, and so we can even manage our cluster definitions, for example, the count of the worker nodes and similar stuff within the Git repository. But as we already saw with the dotted lines, it's not only that we can deploy stuff into the supervisor cluster, we can also deploy stuff into the workload clusters. This stuff we can deploy here can either be real applications or even baselining, for example, an ingress controller or an observability stack. This is great because no matter on which layer you want to have a service cut in your platform, you can always use this to deploy some baselining, which you always want to have, for example, security policies and stuff like that. So that's more or less the multi-cluster management part. And if you want to know more about that, then keep updated with our platform engineering series. There will for sure be more content about multi-cluster management.